So definitely, pregnancy is a very significant stage of life, and malaria has become a big issue, especially in sub-Saharan Africa. And in addition to just having malaria in pregnancy, we have what we call placental malaria, where Plasmodium falciparum infected red blood cells usually will adhere to the syncytial trophoblast of the placenta and accumulate in the intervillous spaces. And this results into complications that end up causing over 10,000 maternal mortalities and over 200,000 neonatal mortalities. Why does this happen? Because of these adverse outcomes such as maternal anemia, severe malaria in the mothers, and eventually we can have mortalities. We also will have adverse child outcomes. We can have miscarriages, stillbirths, preterm labor, low birth weight, and eventually after birth, we can also experience congenital malaria and of course the infant mortalities. I just want to give you a snapshot of the life cycle of malaria. Usually it starts with an infected mosquito biting, then it releases sporozoids that go and infect the liver cells. Then after maturity, they rupture and produce merozoites, which invade the red blood cells. And then there is a cycle that continuously infects more red blood cells, and some mature merozoites will mature into gametocytes, which are then ingested by another mosquito. They mature and the cycle continues. Of importance in our study is now these infected red blood cells will now migrate into the placenta, where they bind onto these syncytial trophoblasts, accumulate there, and cause now those adverse outcomes. Now, throughout this life cycle, Plasmodium falciparum will express different antigens on the surface, including from the sporozoid stage that they are able to infect the liver, and then at the merozoids that they infect the red blood cell. So we have noted that over time, for individuals in malaria endemic regions, they get immunity because of antibody response against these specific antigens. And therefore, we have also noted now in pregnancy that the adverse outcomes that I have just outlined are less prevalent in multigravid women who have had pregnancies more than once. So there is an antigen called VAR2CSA that has been widely investigated. It is on the surface of the red blood cells, and women have had antibody against these antigen and produced antibodies that now become protective. Now, when we also use a knockout VAR2CSA, knockout Plasmodium falciparum parasite, we've realized that we also have some form of adhesion, meaning that it is not the only one that is involved in placental sequestration, and that is the basis of our study. So we recruited a cohort in Western Kenya of pregnant women in their early pregnancy, around 12 to 20 weeks, followed them up to birth, and we observed some key characteristics within this cohort. For example, when we compare the birth weight of the children, we realized that all of them, except one who was at the borderline, had kgs above 2.5. And for the hemoglobin, which is a key factor in malaria infection, we realized that most women had over 11 grams per DL of hemoglobin. Now, the methodology of our study is that we had to use a big range of proteins so that we can screen these women and see if they have antibodies against these proteins. So this is a library. We had 698 proteins that were ranging from merozoid surface antigens. We also had those on the red blood cells like PF, EMP1, STEVAs, Rifin, and Safins. So we did an immunoscreening, and we did this using what we call the alpha screen assay. And it is an amplified luminescent proximity homogeneous assay that works on the basis of having donor and acceptor beads, and then we conjugate now our proteins to the donor bead through streptavidin biotin binding. And then we expect that now our serum from our pregnant women has the antibodies, yeah? So once the antibody and the proteins bind, they bring together or closer proximity between the donor and the acceptor bead, and then that's when we have the luminescence, and it's quite a high throughput assay. So we did that, and then we analyzed our data. From this, we found that over 97% of these protein families that we used here, this represents the numbers of each of the protein families. So the dots are the proteins. So we realized that over 97% of these proteins, we had now antibodies in our cohort. They were able to recognize these antibodies. And that's a good thing, because it is telling us that even from our results, yeah, that are showing that the birth weights were okay, the hemoglobin was good, then it means that they had really acquired a lot of antibodies. Then we had also hypothesized that antibodies response increases with gravida. So we compared primigravida and multigravida and found that there was a good increase. Now we did a differential analysis we wanted to understand now, because we have the increase between primigravida and multigravida, which are those antigens that we can select from this, or that are causing there to be differences. When we found that we had 3 antigens, these are surfins, and this is a blood stage protein. And we have, through more research, we have hypothesized the mechanism of action. And these 2 surfin molecules on the surface of the red blood cells, yeah? So we have now, remember I talked about the addition of infected red blood cells on the surface of the placenta. So we know that now, because of antibodies,